Example number 27. Find the x values of all points where the function has any relative extrema. Find the values of any relative extrema. When we're finding our critical numbers, we have to be careful here, because in order to be called a critical number, it has to be in the domain of the original function. But we have a bit of a problem here because our original function, x, cannot be 0. So we have to not call 0 a critical number. Now, it doesn't mean that we don't put it on our number line. We do, because it is where the function doesn't even exist, but we don't call it a critical number. So I'm going to rewrite my f of x to make it easier to take the derivative as x minus 128x to the negative 1. So f prime of x is 1. Now, using my power rule, I've got a minus times the power, minus 1, times 128, times the base to the power minus 1. So here I have a negative and a negative, which makes a positive, and that's going to be 128 over x squared. So 1 plus 128 over x squared. So let's see if 1 plus 128 over x squared can ever equal 0. Well, we'll multiply everything by x squared, and we get x squared plus 128 equals 0. And look, this is always a positive, and this is always a positive, so we're never going to get a 0. You need a positive and a negative to cancel each other out to get a 0. So there are no critical numbers. Now, it is true that the derivative doesn't exist at x equals 0, but because x equals 0 is not in the domain of the original function, we do not call it a critical value. However, we do put it on our number line, okay, because it doesn't exist for the original function. So we've got to check to the left and to the right of 0. So on the right, I'll pick a 1, and on the left, I'll pick a negative 1, just to keep the arithmetic easy. F prime of negative 1 is 1 plus 128 over negative 1 squared. That's 1 plus 128 over 1, which is 129, a positive. So the function is increasing on the left side of 0. Now be careful, it doesn't exist at 0. So what happens is, and you may remember, there's going to be an asymptote there. It continues to increase, but it never touches that 0 because it would make the original function undefined. There's an asymptote. If I put in a 1, f prime of 1 is 1 plus 128 over 1 squared is also 129. So it's also is increasing forever on this side. And so, as you can see here, this function is always increasing on the left. If you look at this red line from left to right, it's skipping over 0, and it's always increasing on the right. So there are no extreme values for this function. No extreme values. And that's also no extrema, which is plural of extreme. That's our final answer.